In the last video, we looked at example 2, where we were able to take a quadratic denominator and reduce it down to two separate, distinct linear factors. In this video, we're going to take a look at examples 3 and 4, where we're going to see, well, what do we do when we have a rational expression where some of those linear factors are repeated? And that's what we have in this example 3. Notice it has a linear factor of x minus 1, but it's repeated. It's x minus 1 squared. And when we have that, we have to rewrite it like you see below. Like you see, it's a over x minus 1 plus b over x minus 1 squared. And if that was actually a cubed, so instead of a 2 here, if that was a 3, then we'd have to add a plus c over x minus 1 cubed. But it's not. So in this case, we would treat it, once you have it decomposed like this, then you just go ahead and solve like we did in the last example. So we still want to multiply by the least common denominator, which in this case is going to be x minus 1 squared. We want to multiply by that. And so when you do that, the left-hand side just becomes x plus 2. And on the right-hand side, we're going to have a times x minus 1 plus b. Okay. And then we want to go ahead and figure out what a and b are. What would be good values of x to go ahead and plug in here to solve for this? I know most of us are probably going to pick x equals 1 based on our last video, but another good one, since we don't have b times some factor where we could easily pick an x, we could just go ahead and pick 0, because that's something that's kind of simple to plug in. And let's see how this works. So we plug in 1. Of course, 1 plus 2 is 3 on the left side. The a part's going to cancel, and we just get b equals 3. So that part's easy. Now, when we plug in 0, the left-hand side is 2, and then we have 0 minus 1 is negative 1, so we have negative a plus b, but we know b is 3, right? So we have 2 equals negative a plus 3. We just figured out what b was equal to right here. So then we now know that a is equal to 1. And that means that our original rational expression, x plus 2 over x minus 1 squared, is equivalent to 1 over x minus 1 plus 3 over x minus 1 squared. All right, so there's one example. In that example, I'm not asking to do any integrals. Let's go ahead and actually evaluate an integral. Similar type of problem here in example 4. So in the denominator here, the x squared, this is a repeated linear factor. So we need to go ahead and rewrite the whole thing. So if we have 3x squared minus x minus 3 over x plus 1 times x squared, how are we going to go ahead and rewrite that? Well, we have a linear factor of x plus 1, so we have a over x plus 1. And then our repeated linear factor, so we need one factor that has x, and then we need another one that has x squared. So this is b and plus c. And then we can multiply both sides by our least common denominator, which is going to give us 3x squared minus x minus 3 equals ax squared plus b times x plus 1 plus c times x plus 1. And so, how about let's start with x equals 0. Starting with x equals 0, we get negative 3 on the left side. A times 0 squared, the a's go away. The b goes away, and so we're left with c times 1, which means c is equal to negative 3. Okay, what would be another nice choice for x here? How about x equals negative 1? So when we choose negative 1, what we get on the left side? We get 3 times negative 1 squared is 3, plus 1 minus 3 is equal to a. And then the last two terms go away because of that negative 1, right? So we have negative 1 plus 1 is 0, and negative 1 plus 1 is 0. Those two terms go away. And so we get a is equal to 1. Okay, and there's no real obvious choice for what we should pick for x to find out what b is. Let's just pick something small and something that's easier to plug in. So, I mean, we could pick 2, 3. I'm going to go ahead and pick positive 1. It's probably the simplest thing we could plug in, but you could really plug in anything you wanted. It's just the simpler we pick, the easier it is to go ahead and simplify after we plug in. So when we plug in 1, on the left-hand side we get 3 minus 1 minus 3. So we get 3 minus 1 minus 3 equals a plus, looks like 2b plus 2c. And simplifying, the left side equals negative 1. We already know a is equal to 1 plus 2b, and we know that c is equal to negative 3. So we have 2 times negative 3. We're almost there. So we have negative 1 equals, and we have 1 plus 2b minus 6. Which gives us that 4 is equal to 2b, which means b equals 2. And so our original integral here, we get 3x squared minus x minus 3 over x plus 1 times x squared. We can now rewrite that as the integral of 1 over x plus 1 plus 2 over x minus 3, c is negative 3, minus 3 over x squared. And evaluating, we've done this a few times now, so 1 over x plus 1, we know that's the natural log of the absolute value of x plus 1. In a similar fashion, the next term is going to be plus 2 times the natural log of x. Then lastly, if we treat that last one instead of the integral of 3 over x squared, we could treat that as the integral of 3x to the negative 2 dx, right? And then you just use the power rule on it. So if you add 1 to that, you get negative 1. There's already a negative there. So this is going to be what? Positive 3 over x plus c. And that's our answer. So that's going to do it for this video. We're going to cover one more video in this section. I'll see you in the next video.